Have you ever wondered what is responsible for the counting in traffic light and in your clock? In this video, we are going to show you how to build a simple 555 timer based counter on a breadboard. This is a 55 timer, basic 55 timer counter connected in an astable multivibrator mode. So 55 timer has 8 pins. Pin 8 is the VCC, or you can call it positive side. Pin 4 is called the reset pin. We have pins 2 and pin 6 are connected to this RC network. Then pin 7, or known as the discharge pin, is connected between the two 10 kilo ohm resistors as shown here. Pin 1 is your ground, and this 220 kilo ohm is called the current limiting resistor. So these are all we need to construct a simple counter using 555 timer. We need power supply, set of components. We have 4 resistors, 1 capacitor, LEDs, 555 timer, and the rest are jumpers. We have 1 breadboard. So let me show you how to construct an astable multivibrator. The configuration we're going to use is called astable multivibrator, which means free running. So let me start by placing the chip. So if you are holding the chip, you notice a notch, and this notch tells you you start counting your right. So if you are pointing at it, the first terminal is by your right, which is 1, 2, 3, 4, 5, 6. So you count anti-clockwise. So you count pin 1, 2, 3, 4, 5, 6, 7, 8. So basically it's an 8-pin integrated circuit. So notice how I place it on the board. So you have to place it between this groove. This groove divides this set of pin from the other set of pin. By so doing, you isolate the pin so that each one is individual or is independent. So the second step is to build our network, RC network, which means resistor and capacitor. So let me put one 10 kilo ohm resistor this way. We have another 10 kilo ohm resistor from this to this. So you can actually adjust the length so that for convenience. So you can just then we have our capacitor. So notice that we are using a polarized capacitor. This is 10 microfarad capacitor. So the way to differentiate negative and positive terminals is that on the negative terminal there is an indication, a white line with arrow pointing. This is an indication that this particular terminal is negative. So I'm going to connect the positive side of the capacitor to this 10 kilo ohm resistor. Then the next step after building this is to connect. So I'm going to use these jumpers. Sometimes it's convenient to use. So I'm going to use connect this side of the 10 kilo ohm resistor to this side. I'm taking this to be my negative or VCC, while this to be my ground or negative. So I'm connecting this terminal of the 10 kilo ohm resistor to my VCC. Then the second step is to connect This is our negative terminal of the capacitor, so I'm connecting the negative terminal to the ground or the negative side of the battery. If you are following the diagram, pin 4 and pin 8 are connected together. So and pin 4 and pin 8 are connected together, and they are taken to VCC. So this is our VCC, or the positive side. The same way, pin 6 and pin 2 are connected together. So this is pin 6, this is pin 2, are connected together. So we are going to connect pin 1 of our 5-5 timer to the ground or negative side. So having done that, so between these 10 kilo ohm resistors, we connect it to pin 7. Pin 7 is connected between these two 10 kilo ohm resistor. Then the pin 2 and 6 are connected to the point between this 10 kilo ohm resistor and this capacitor. So this is where our pin 2 and 6 are connected. So the next step is to so we're interested in visualizing the output. So we are going to use light emitting diode. So we are placing our light emitting diode here. You can place it anywhere, depending on what is convenient for you. We are going to use 220 ohm resistor as a current limiting resistor. So this so what I'm going to use this connector or jumper wire to connect it to connect this the negative side of the light emitting diode to the power supply, negative side of the power supply. So for 5-5 timer, pin 3 is the output. So you locate your pin 3, the row where your pin 3 is, and now connect it to the other end of the the 220 ohm resistor. So we have finished our connection. So there is one important point that I need to highlight. If you notice this column or contact is not continuous, there is a gap. So we have to we have to put a jumper so that we can take the supply from here to here. So I'm going to choose jumper to now make the connection. So by so doing, this part is complete. So our ground is complete, or the negative side is complete by so we jump the negative to this so that we can supply to this LED. So I think we are done. So the next step is to connect our power supply. So this is positive, this is negative. So with things being equal, we should be able to see the LED flashing. Okay, so we have constructed our 5-5 timer based astable multivibrator, or you can call it a free running. This particular circuit has a lot of application, from traffic light, clock, and to your car trafficator. So when you want to trafficate light, what you are doing is to now activate a a counter that will be making that noise, so that you can be making that indication of flashing light. So this particular circuit has a lot of applications, not only limited to what I mentioned. You can use it in generating clock for microprocessor or in microprocessor applications, where you need to create build a clock or generate a timing signal for the microprocessor to execute some instructions. So let me briefly recap what we just did. First of all, you place your 5-5 timer, and don't forget that the 5-5 timer has a notch where you start, where tells you the beginning of your pin 1 or where the pin start. And when you are looking at the notch, you count anti-clockwise, which is pin 1, this is pin 4, pin 5 here, and pin 8. So some of the basic things you should know about 5-5 timer is that pin 4 and pin 8 are connected together, pin 2 and pin 6 are connected together. That is if you want to build it as a free running mode like this. Then you build your RC network. RC network means your resistor and capacitor network. So here what we did is we have two resistors here, 10 kilo ohm resistors. So between the two 10 kilo ohm resistors, so we connected our pin 7 of the 5-5 timer, and between the 10 kilo ohm resistor and the capacitor, we connected our pin 2 and pin 6. Then the other side of the capacitor, we connected it to the negative side of our supply. Then the end of the capacitor, the end of the 10 kilo ohm resistor, we connected it to the VCC or the positive side of our power supply. To visualize what the 5-5 timer is doing, we use LED, and pin 3 is the output of a 5-5 timer, and we connected our LED to pin 3 via what is called a current limiting resistor. The reason why we need a current limiting resistor is because we use 9 volt and our LED is just 2 volts, approximately 2 volt. So we need to limit the amount of current as well as the voltage across the LED. If you are new to this channel, kindly subscribe for more videos and hit the like button. If you are already a part of this family, don't forget to hit the like button.